everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK-based schools, and now I run a tutoring business where I've helped thousands of students to get better grades in computer science related courses. And what we're doing today is I just thought I'd go over very quickly binary addition, maybe a couple of weird examples where you might not have seen it where you have to add three numbers together, and also having a look at binary subtraction as well today. So let's get into it. So let's say that we've got quite two large numbers like this. What I'm going to do is I just need to convert them into denary to start with. AQA, you have a calculator, so you can use a calculator, that's absolutely fine. OCR and Cambridge International, you do not, so get into the habit of using it without. So let's do 174 first, so we're going to put two zeros there, and then we put a 1 here, because that is the first number which is either equal to or less than that. And then if you're practicing your non-calculator stuff, just do this. I always say, take a little bit of extra time because why not? It's important stuff. Guarantee those marks in the exam. And then that's just take a few seconds longer ultimately because we want to make sure that we absolutely get those marks in the exam. And then 8, 4, 2 for 16. For 14 there. 8, 4, and 2. So that's going to be 174. Now, a little shortcut as well that you may want to know is for 255, I'd know that there's going to be all ones after the 256 there. If it were 127, so if it's one less than the one up there, it's just all ones of the thing before it. 63 would be all ones, so it'd be 6 ones. So that's just a little shortcut if you want to be able to use that. Now, let's go through a couple of rules. It may have been a little while since you've looked at binary addition. It might have been the first time that you're looking at binary addition. So with binary addition, essentially what it is there can only be ever two numbers that you can write down in the answer box. So it's 0 or 1, which simplifies it. Where it gets complicated is the carries. 1 and 1 is 0 carry the 1, which where the logic of that happens is because it gives you 2. Okay, so that then has to move over to the next one because binary is in base 2. Don't worry about that too much, about the theory and all of that behind it. Just remember 0, put a little 1 up there. If you have 3 ones, you have 1, 1, and 1. That's going to be a 1 down here and then a 1 up there. Okay, so let's have a look at how this works. So I've got a 1 here, 0 plus 1. 1 plus 1 is 0, carry the 1. Now here's our first 3 1. 1, carry the 1. Another 3 ones, 1, carry the 1. 2 ones, 0. Carry the 1. 3 ones, 1, carry the 1. 2 ones again, 0, carry the 1. 3 ones, 1, carry the 1. And then that's just going to put that there. I could put a 0 here. But then this is going to just work in this particular way, and that's going to be all good. If they do give you this, and let's say that you try and be a little bit sneaky, and what you do is you add them together and then just convert that into a binary number, they do dock you marks for that. They want to see that you've actually used the binary addition rules. So that's a good, again, just telling you, I don't want you to lose marks. So don't do that where you just add them and then convert it into a binary number. And that goes for binary subtraction as well. Let's have a look at 3 numbers then. So let's just quickly pop these down so that you can see how this works. So you've got 0, 1, 0, 0, 1, 1 for 19. 66 is going to be 0, so it's just going to be 64. Then we just need to get a 2. 0, 0, 0, 0, 1, 0, and then 74. So 0, 1, and then we just need to get a 10 there, so that's just going to be 8 and 2. Oh, just going to put a 1 there. 0, perfect. Okay, so we've got that there. That's sorted. So let's have a look at how we add three binary numbers together. Now, it's just going to be the same rules that we're going to use in this case, because I don't think there's going to be any situation where we get 4 ones here. So we're going to put a 1 down here. 1 plus 1 plus 1, so 3 ones. 1, carry the 1. 1, and then this is going to give us a 1 here, another 1, relatively straightforward here, people. So then we've got 0, 1, and a 1 there. So then that's going to be all of those, just the same as what we were doing before. Let's say, just to show you the sort of strange example, that if you did have 4 ones, what do you do in this case? Now, the logic of this is that if you think about it, 4 ones have to make 4. So what we're going to do is we're going to, instead of moving it into this one, the carry actually jumps over this one and goes to here. And then you would go from there. That's a little bit more advanced, and it's a little bit of a strange circumstance to come up. But still, it's good for you to know. So if you get 4 ones, just remember to jump it over, because it's actually going over it's going 2 columns away. Now, so the next part of this, of what we need to do, is do binary subtraction, which this is going to be is going to use pretty much exactly the same rules, apart from what we have to do is we use the mathematical rule that if we add a negative number on, that gives us the same effect as taking it away. So it's exactly the same principle, but we just need to remember that we need to 2's complement the negative number and then add it on. That's the principle behind it. So let's have a look at how we do that. So 65 is positive, so let's just pop that in there. So that's going to be 1, 0, 0, 0, 0, 0, 1. And that's all good. Now for 43, it is a negative number. So first of all, convert it into a positive number. 1, 0. And then that's just going to be 1, 0, 1, 1. So that's positive 43. And then what I need to do is I need to convert this into a negative number. So this is going to be, so we go and find our first one. Everything at our first one and before it stays the same. So it's only that one, so that's going to stay the same. Everything after it is flipped. So that's going to become a 0. This becomes a 1. This becomes a 0. This becomes a 1. This becomes a 0. This becomes a 1, and this becomes a 1. So that's now negative 43. So we just write that in underneath there. 0. If you haven't seen my other lesson on 2's complement, there is one on there, so please do check that out if you're unsure about how that works. And then we just do the normal binary addition method. So 1 plus 1 is going to give us 0. Carry the 1. 1, 1, 0, 1, 0, 0. Carry the 1. 0, and then carry the 1. And using that overflow error there, what it does is, as you can see, the number actually gets smaller because this gets forgotten about, this one. And what this will do is this will actually give us the correct number because of that overflow error. So that's how it does what it needs to do. And anyway, let's just look at this strange example here, because I just wanted to remind people of this. Some people sometimes forget that if you minus a minus, it's the same as adding it. So in this case, all you would have to do is, if you see the double negative, just change that to put it as positive 14. So all you have to do is put 22 under there. So 0, 0, 0, 1, and then just go 0, 1, 1, 0. So that's just 22. And then we're just going to put normal positive 14 under there, because the double negative changes that to a positive. Okay, and then, so it should be a 1 there. And then all you have to do is then just do normal binary addition. So 0, 0, carry the 1, 1, carry the 1, 0, carry the 1, 0, carry the 1, 1, 0, 0. Okay,